So I'm Chenhao Tan. I'm now a postdoc at the University of Washington. I'm moving to Colorado next month to start as a faculty. Here I'm presenting joint work with Dallas Cart and Noah Smith down at UW. And the subject of this talk is about relations between ideas, and you can see some examples in the title, such as friendships, rivalries, and trysts. And later on, I will elaborate what I mean by these terms. I just want to give you a warning before there won't be neural networks in this talk, or squash networks. Okay, now this is relation between ideas, and to make concrete what I mean by relations between ideas, I'll give you a few examples. So first, especially in the political domain, there are many ideas that we intuitively think are competing with each other. For instance, on the issue of abortion, there will be pro-choice versus pro-life. On the issue of immigration, there will be undocumented immigrants versus illegal alien. And here, undocumented immigrants will suggest that these people are not actively breaking the law, so they should deserve a path to citizenship. While illegal alien emphasize on the differences and otherness, so maybe they should be deported. And meanwhile, there are ideas that always go hand in hand together. For instance, small government and free market are often used together, and in our own area, word alignment has been an important component of machine translation. And this kind of competing relationships or friend relationships have been hypothesized or qualitatively described in many existing works, for instance, including Marketplace of Ideas. And in this work, the first of our main contribution is to provide a quantitative framework to systematically describe relations between ideas, to think about what makes competition and what are the possible other ways that ideas may relate to each other in textual data. And secondly, it turns out that this quantitative framework also allows for very effective explorations on a wide range of data sets. So the idea is that if suppose there are n ideas, that means there will be n squared possible relations between them. And using our framework, we can identify the meaningful relationships on the right side of the presentation very quickly from the left side of the messy networks. And the focus of this talk is on the relations between ideas. So we are going to use very standard approaches to extract ideas from texts. And this includes topics from LDA and keywords from the Fighting Words paper. And previous work have both used these approaches to represent ideas vaguely. Cool. Now let's start with the first part of the talk. We are going to think about how we can quantitatively describe relations between ideas. And the input to our framework is that there is a corpus of documents over time, and each document consists of a set of ideas that are already extracted. So discrete units, any discrete units could work. Let's make this more concrete. For instance, that we have these two keywords or topics as ideas, undocumented immigrants and illegal alien. And we are thinking that they have some kind of a competing relationship. And one way to capture this kind of competing relation is that through our favorite statistic, coherence. This has driven a lot of NLP research. And in this case, we may think because these two represent different ideologies, so they will be used by very different people, they will seldomly occur in the same document or same news article. And we'll use the observation that they really co-occur, or the quantitative observation that they really co-occur as a sign of competition. However, this is not enough, since coherence doesn't really capture which one is winning or losing, which is a very coherent, a very inherent part of competition. So especially if we have time series data, we can actually look at their frequency over time. And in this case, hypothetical figure, we can see the undocumented immigrants is going up while illegal aliens going down. And in order to capture this kind of competition in frequency over time, or this notion of undocumented immigrants win out over illegal alien, we are going to use Pearson correlation to capture these relations. And that's the main idea of this work. We are going to combine coherence and prevalence correlation to describe relations between ideas. And coherence captures the within document interaction between ideas, while prevalence correlation captures the prevalence correlation between ideas across multiple documents. And from now, I'm only going to show you real data that we got from news articles. So this is from a corpus on immigration from major US newspapers from 1980 all the way to 2016. And it turns out that these examples I was using was prominent enough, they stand alone as topics just from LDA. So one topic, the first two words is undocumented immigrant, the other one is illegal alien. And from now on, whenever I separate two words with a comma, it means it's a topic. And what you see here, the y-axis is frequency, and the x-axis is time. And between these two topics, we can see that the undocumented immigrants is going up, while illegal alien is going down. So on the prevalence correlation part, they are anti-correlated. I cannot really show the co-occurrence statistic on the figure, but I show it in text. These two indeed really co-occur. And we refer to these kind of relations between ideas head-to-head competitions. And in general, since we now have two dimensions, this gives us 4 quadrants. And I will give you examples from immigration data from each quadrant to illustrate what we mean by the relations in that specific combination. So first, let's look at friendship. Friendship refers to ideas or pairs of ideas that are correlated in terms of the frequency and are likely to co-occur in the same document. And the example in the immigration data set is undocumented immigrants topic that we saw earlier, and another topic starting with President Obama. And you can see from the time series, these two are almost completely tracking each other from the 1980s to 2016, and they both started to take off around 2008. And they are also likely to co-occur in the corpus that we got, so their relationship is almost like friends in real life. And next, now we are moving on to the off-diagonal quadrants, which are the less expected ones, and I personally also think are the more interesting ones that we got out from this framework. So now let's look at the bottom one, which is arms race. So this refers to ideas that are correlated in terms of their frequency, but seldomly co-occur. And this example we got from immigration data set is a topic on immigrant deportation and a topic on Republican Party. These two, based on their time frequency data over time, they are indeed very correlated in terms of their prevalence in news articles in the US, major news articles. But they seldomly co-occur in the same document. It's almost like the Cold War scenario about the relation between USSR and the USA, that they never met on a battlefield, but they are pushing each other to grow in terms of their military equipment. And in textual data, this is usually because these two ideas or topics are driven by the same underlying cause. And finally, let's look at the most counterintuitive quadrant in this framework, Trysts. This refers to ideas that are anti-correlated. So one goes up, the other goes down. But surprisingly, they turn to co-occur. And this example is a topic we just saw on immigrant deportation and a topic on detention and detainee. So it's kind of one step in the process of immigrant deportation. And we can see that the frequency of detainee or detention has been going down, while immigrant deportation has been going up. And because these two are quite relevant, so they turn to co-occur overall. And this is usually indicates that two ideas were together during a period in the history, and then with on different paths. One grows very popular, one starts to fade away. And in this case, it's because that the US has been starting an effort to decrease the number of detention centers in the US. Cool, now we have this nice framework and 4 quadrants to describe relations between ideas in a quantitative way. And the next question we are going to explore in this paper is to think about how we can use them to effectively explore relations between ideas. And in order to do that, we tried a wide range of data sets, mostly from the newspapers or research articles. And you can imagine why in research articles different hypotheses may compete. And I have illustrated that in news articles this is very common, especially on political issues. In the interest of time, I won't go into details of all these data sets. I will focus on the rest of the talk on terrorism. And before we look at the exploration process, let's start to first look at take a quick look at the general distribution between these two dimensions or two statistics I've been using. One is the co-occurrence, and the other is prevalence correlation. And each dot in this figure represents a pair of ideas, and its corresponding value represents the two statistics I'm using. And there are more discussions in the paper about general properties of this joint distribution, and in here, because time is limited, so I will just point out a quick fact. These two dimensions tend to be correlated in all the data sets that we have tried, no matter how we represent ideas. But for now, I just want to point out that there are many pairs in each of these four quadrants. So that means all the four types of relations I've described, we can all observe in real data. But we won't be able to have time to look at each pair, so we hypothesize that extreme pairs are the interesting ones. So we are going to rank these relations based on a metric which we call strength that combines the product between the correlation and the co-occurrence. And if we rank all the pairs based on this metric, we can identify the extreme pairs in each quadrant, as shown in these circles. And that's how we are going to explore a new data set, or each of the data sets we have in our experiments. And now let's look at terrorism, and we start with keywords. And I want to highlight this. Personally, I think the most interesting observation we got from this paper, and I believe this is actually the first time this has been documented in any data-driven studies, or any observations, really. So this is an observation between two keywords. One is Arab and another is Islam. And they turns out to be the second strongest relation in Trysts. So that, I just want to remind you, that means that they tend to co-occur because they are clearly related words, but they have been going on different paths, as you can see from the figure. Arab has been declining while Islam is going up. I just want to remind you this is in the context of terrorism coverage in the US. So this may suggest that the US has been shifting from a regional focus to a religious focus in terms of terrorism coverage. And there can be many different reasons to explain this, and that's kind of beyond the scope of this talk. And I think part of this paper is to provide this framework so that we identify interesting relations that's worth further investigation for social scientists or for maybe some people who want to understand how their corpora has developed. And that's not the focus of this work. And so next, we are going to look at topics. And it turns out that I'm going to show you a few top relations between ideas from topics. And they will center around this topic called federal and state, which corresponds to the US domestic policy against terrorism. And here on the right, it turns out that this topic is in arms race relation with Afghanistan, Taliban, and another topic on Pakistan, India. And these two are in arms race means that they seldomly co-occur in the same document, but their frequency closely track each other. This is because both are driven by 9/11, and after 2001, all of them are taking off in terms of frequency, but they correspond to different aspects of this issue, so they do not really co-occur. And one interesting observation I want to point out is that these relations actually, their relations are consistent with structural balance theory. In this case, we can see that Afghanistan, Taliban, and Pakistan, Indian are with the strongest relation in France. And by the way, in this figure, the number represents the rank in that particular quadrant. And for people who have been longer, I just want to highlight the rest part of this figure. And federal state is also in head-to-head relation with Iran, Libya, and Israel, Palestinian, because they were the focus of terrorism discussion back in the 80s, but they have been going down in terms of the frequency in the past 20 years. And this is the main quantitative result, the only quantitative result I'm going to show in this talk. I want to highlight why our framework supports effective explorations. And I just want to pay attention to these two numbers. Based on our metric, which is joint column, this relation between Arab and Islam is ranked second. But if you only look at a correlation, it's ranked beyond 1,000. So it will take a long time for you to realize this is an interesting pair, or you will never find them. Of course, we also look at ACL data, and Martha has already reminded me a few times, so I won't go into details. But for people who you have your own data set, you should pay attention to this slide. Our awesome undergrad Nico Rush developed this visualization tool that allows you to play with our framework very easily and is available on GitHub. Thank you. I'm happy to take questions.
So while people are thinking of their questions, can you go back to your slide on the ACL data and tell us what that was about?
I just like people pay attention. I think Jason might have a question. But
tell us a little bit about the slide.
Okay, sure, I can. Yeah, so it turns out that so this is not really cherry-picked. So all these are top 10 relations, I believe, from ACL data. And it turns out that it centers around machine translation, which is not surprising. And machine translation is in friendship relation with word alignment, and is in arms race relation with sentiment analysis, because they are kind of big application area after the takeoff of statistical NLP approach. And machine translation had a Trysts with rural forest methods topic. It's kind of hard to exactly pin down what that topic is about, but I think around there was back, I don't know, the full history of this part-time, but back during a period, syntax-based machine translation methods was popular, so they tend to co-occur. But nowadays, these rules of forest-related approaches are fading away in NLP papers. And head-to-head is the most controversial one, is in head-to-head relation with discourse. I want to comment more about that, but if people ask, I can elaborate a little bit more on that.
Thanks. This is very cool work. So I'm thinking about applying this to scientific writing. You mentioned an example early on, in fact. And I wonder, have you thought about using these methods to improve recommendation, for example, assigning appropriate reviewers to papers who might be sympathetic with the methods but bring a range of different perspectives to it?
Yeah, I actually never thought of that as a potential application scenario, but I think definitely, I think part of this is also driven by my recent interest to look at temporal data, and I think in review matching systems, it definitely makes sense to consider how fields are moving and also how personal interests are evolving over time. And it may take some work to apply this to that problem, but I think it's definitely an interesting potential problem to think about.
Thanks.
Thank you.
We have time for maybe one more question.
I think there was a question
there. My understanding is you said you use topic modeling for these. Is that correct?
For this particular one, yes. We also use keywords to identify ideas.
Okay, so since this is based on topic modeling, how reliable do you think this is based on?
I guess there's a big question about what reliable means, and in general, for exploratory work, it's hard to evaluate. I think we have both used topics and keywords to demonstrate that our framework is general across different representation of ideas. And I think our work is kind of viewed as a first step for you to approach the data, to think about what are the possible interesting questions, hypotheses, or theories you can think of. And after that, you, of course, need to try many different approaches, and topic modeling is just one way to do it. And some of the visions that we saw, indeed, are verified both using topics and keywords. And there are more details about that in the paper.